Greg Cutrell. I'm a research associate with Duke University, and with the help of Anna Wilson, Jing Tao, and Dr. Anna Burrows from Duke, and Dr. Doug Miller from UNCA, I'm going to talk a little bit about the federal grants that have been provided from NASA and NFF to fund precipitation and hydrology studies in the Southern Appalachians. So just a quick overview of why these projects even came to be. The topic of the day is the 2004 floods. And Brune and Burrows looked at the percentage of annual rainfall that came from cyclones from between 2002 and 2011. And you can see for the southeastern U.S., 2004 was a big year for tropical rainfall in the U.S., where most of southeastern United States received up to 25% of its annual rainfall from tropical systems. And then just looking a little closer into 2004, even in portions of western North Carolina, some areas got up to 40% of its annual rainfall just from tropical systems during 2004. And then looking at just a few of the storms that came through southeastern U.S. Although western North Carolina was influenced by a number of different systems, the main ones were Frances and Ivan. Parts of western North Carolina received almost 16 to around 20% of its annual rainfall just from one system that came through during September, and then a week and a half later, Ivan came through and also gave western North Carolina about 10 to 12% of its annual rainfall just for one tropical system. And with lots of rain during short periods of time, as we talked about, we have floods. Places in western North Carolina received anywhere from 25 to greater than 50-year floods during Frances. And the flooding was not as bad in Ivan. Oops, wrong button. And looking at the basins that exceeded or was at the flood stage, a good portion of western North Carolina was under the floods, was at or above flood levels for Frances. And even though Ivan didn't produce as much rainfall, the basins never really recovered from all the rainfall that occurred. So there was, again, more flooding during Ivan. So the original project that really started everything I'm going to talk about today was the Pigeon River Basin Rain Gauge Long-Term Network. It started in 2007, and it's finalized in 2009 and still going through this year. We have approximately 30 locations, and what makes this study a little different to what you'll find of the more recent rain gauges that have been placed around Buncombe County that we've heard about today is that these gauges are in high elevations, they're on ridges, they're hard to get to, and most are not on private property, but some are. And just to give you a reference of where some of these gauges are, this is the Appalachian Trail in the Great Smoky Mountain National Park. This is Mount Sterling, Cataloochee Divide, and the Pisgah National Forest in the southern part of Haywood County. And we also have scattered mountaintop gauges across Haywood County, and these are mostly on private property. So that's been going on since 2007. We've gotten some good results from that, but I'm going to talk more about the more current activity that's been going on in western North Carolina. And that is all due to the recent GPM launch on February 27th from Japan. It is upgraded precipitation satellites to replace the TRMM, the Tropical Rainfall Measurement Mission satellite that was launched in '97. The new satellite expands the coverage of precipitation from 40 degrees north and south to the Arctic circles. And also this new satellite can detect light rainfall and snowfall. And the new GPM satellite can provide updated global precipitation maps every 3 hours compared to about every day for the TRMM satellite. So the TRMM satellite is still in operation, but it's slowly falling back to Earth. So here's the GPM satellite, a picture of it. And with any new scientific satellite, we have to validate the satellite and make sure that it's taking the correct measurements and correct the algorithms if it's needed. So the first ground validation project is called IFEX, the Integrated Precipitation and Hydrology Experiments. And this took place and is taking place in Western North Carolina for the most part. So why was Western North Carolina interesting? Well, one, we already had the dense rain gauge river basin network in Haywood County. Western North Carolina is also one of the hotspots in the U.S. for annual precipitation. And then, of course, we have the Southern Appalachians with complex terrain and complex atmospheric processes, which gives a good test to the new satellite that was launched this February. So the main goals of the ground validation is to improve the retrieval algorithm of the new GPM satellite. There's studies in the past where they compare rain rates to the TRMM satellite, and this has been done by Jean Tal at Duke, where she looked at times when the satellites saw rainfall, but the rain gauges didn't, and that's called a false alarm. And then there's times when the satellite doesn't see rainfall, but the rain gauges actually do record rainfall. And this is due to various reasons. One is just the complex topography. Another is the angle at which the satellite is viewing the surface where the rain gauges are at, because the satellite is not always right above the surface. It could be viewing at a different angle on the surface. And there's also just complex precipitation processes in the mountains that the satellite was not able to pick up. Another purpose of the ground validation project is just to have a better understanding of the precipitation processes in the Southern Appalachians, and to get a better understanding even of just the ground-based and aircraft measurements themselves. And below is just a short graph with the lines there are 3 different instruments using 3 different theories to measure precipitation. And each instrument, as you can see, gave a different rain rate over the 15 minutes than the other. So that's something else we'll look at. And finally, to try to explain and quantify the uncertainty of the GPM measurements so that end users will know how to interpret the data. So there's 3 parts of the IFEX campaign. There's the extended observation period, which began September of last year and will continue through the end of this year. This mostly consists of the rain gauge network in the Pigeon River Basin, which I showed earlier, along with new instruments that have been placed out, and micro-rain radars that look vertically into the atmosphere and gets fall velocity of raindrops. And then distrometers were placed around Western North Carolina. Then there was a really fun time, the intensive observation period, that took place this year between May 1st and June 15th. Aside from all the instruments in the extended observation period, the IOP contained aircraft and radars that were brought down from NASA, NOAA, and then the other component was the modeling aspect, the hydrologic modeling aspect of the project. And they've been doing benchmarking. During the IOP, they did 24-hour operational forecasts. And finally, they'll be looking at the results and synthesizing them. And for the project, they were modeling over the 4 basins in the southeast, Upper Tennessee, Catawba, Santee, Yadkin, PD, and Savannah. So consider when looking where to put instruments across Western North Carolina, we had to consider different atmospheric processes and where the precipitation comes from. One thing we had to look at is the westerly systems, that cold fronts and mesocyclones, mesoscale systems that come through. We have the big rainmaker, which is the southerly rainfall that comes from the Gulf of Mexico and also the Atlantic. And then we have the intermountain induced rainfall that could, for example, there's a cedar feeder mechanism, which is how raindrops interact with cloud particles as they fall through clouds. and then also the suppression and initiation of convection, which we saw a lot of yesterday. And here is the final graph of picture of where all these instruments were placed. We have instruments actually on Tennessee in the valley to sort of get the initial westerly rainfall. We have instruments on the southern escarpment of the Appalachians, a number of instruments in the Intermountain region, and one thing we wanted to do was be able to find two locations where we can get a ridge and a valley comparison during weather events. And then we have instruments as far north as Mars Hill and as far east as Mount Mitchell. And these other instruments over here, east of the escarpment, was actually part of NOAA's part of the projects. And each of these sites that you see on the image here has a Parseval distrometer, which uses a laser to detect raindrop fall velocity and raindrop size. And then we have a little more simpler tip and bucket rain gauges that can get accumulation and rain rates. So for the intensive observation period, or the IOP for short, NASA brought down some more advanced distrometers, the 2DVD, which actually uses two high-speed cameras to measure the raindrop size and fall velocity. They brought a large radar called the NPOL, is a large S-band radar, and paired with the S-band radar was a D3R, which had a KU and a KA band radars. And then NOAA brought their X-band radar from Oklahoma, and this radar was a little special for us, is because we actually put this radar in Haywood County on a low ridge, so it actually could see more of the valley weather instead of, as mentioned before, the beam blockage that can occur from the radars outside of the mountains. So NASA had a ER-2, which is a high-flying aircraft. It's a simulator for the GPM satellite that was launched this year. And the goal was to get the airplane to fly underneath the radar, underneath the satellite when there were overpasses from the satellite and ran at the same time. And then University of North Dakota brought their Citation, and this plane actually flew within the clouds. I think they stayed out of the thunderstorms for safety reasons, but they were mostly interested in the ice microphysics of cumulus and cumulus congestus clouds. And this was an image over western North Carolina from the ER-2 during May, just to give you an idea of how high the ER-2 actually flies. And finally, there was a third plane, NOAA King aircraft, and they were mainly interested in the soil moisture. And they also had a simulator for a soil moisture active passive satellite that's going to be launched later this year with NASA. And the pink lines represent the flight path for the airplane. And the red lines represent the field sites where we actually went out in the field and took ground validation measurements while the plane was in the air. And this area is Linville to Boone is about what this area was covering. Some more instruments. Maggie Valley was sort of a hot spot for us. The NASA brought down their Achieve setup, which had a KW and X-band radars, as well as numerous other atmospheric instruments. And this was sort of the test bed for high temporal and spectral resolution data. And this was ideal for supporting the algorithms and retrievals from not only the GPM satellite, but the ER-2 that was flying over during certain rain events. So what have we learned? Well, there was a lot of data collected. It's still being processed and analyzed, and the project's actually not over yet. The extended observation period doesn't end until later this year. This is a fog trailer. It has a particle counter on it, along with some other instruments. We just moved that to Haywood Community College. But just want to talk about some of the preliminary results from the IOP, one case that happened during the IOP, and some results from the hydrologic modeling aspect. And one of my colleagues made a graph for our Pigeon River Basin rain gauges where they took the average rainfall for May 1st to June 15th for each year since 2009 at the different locations inside the basin. And unfortunately, although we did get some good rain events, it was actually below average for what the Pigeon River's seen in the past 5 years. So it would have been a little nicer if it was a little wetter, but I think they still got what they wanted. So going back to the NOAA radar, the NOXP, which was placed in Haywood County, this image on the bottom is the radar reflectivity accumulation of rain during the May 15th events. And above is a scatter plot of the comparison of rain accumulation of the radar to the actual rain gauges we have in the Pigeon River Basin. And at least for this one event, the radar was slightly overestimating the rain rate for this one storm. And then on the right, we're also looking at more of the raindrop size distribution across Western North Carolina and Tennessee and how it might change through time and over different parts of the mountains. And in the bottom right image, we have our stations listed, which are in the graph above. The elevation of each station is on the y-axis. The size of the circle represents the average size of the raindrops, and the color is coordinated with the circles above on the graph. And just a couple of things to point out that we found is that the western sites west of Asheville, P2's at UNC Asheville actually, so this gives you a reference. A lot of these raindrops were actually smaller than other parts of Western North Carolina. Generally, the higher elevation you go, the larger the raindrops were. And also the western escarpment and the southern escarpment got more of the larger raindrops, which occurred during the afternoon, which is probably why there's more of the larger raindrops with the thunderstorms and heavier rains involved along the mountain ridges. And so as I mentioned before, the ideal case was to get an aircraft over precipitation and then also get the radar viewing the precipitation. And even in one case on June 11th, they were able to got lucky and the satellite overpassed Western North Carolina as there was precipitation. That was by the main S-band radar in southern Rutherford County, and the airplanes were involved, so they got everything all at once. And this green line on this graph represents the flight path of the GPM satellite on June 11th, and below is a reflectivity plot from the S-band radar in southern Rutherford County. And to the right is the same day, but later on, where more cells actually developed in Western North Carolina. I'll just give you a reference. This is Haywood County right here. And so both planes, the ER2 and the Citation, were involved with flying over this precipitation and in it. And this image in the middle is one instrument from the ER2, the high-flying plane. Each column represents a different frequency of the instrument. The colors represent cold to warm, and as you go down, the time's advancing. So as they flew over the cells, the higher cloud tops would be colder, so you can see individual cells that the ER2 was flying over on June 11th. And finally, there was the operational hydrological forecast that took place during the IOP every day. It was every 24 hours. The IOP domain was smaller than the IFEX domain that originally pointed out. And the IFEX domain was looking at the Pigeon, Upper French Broad, Upper Catawba, and Upper Yadkin basins. And they had 12 headwater catchment points that they were using for reference, for observations. And when running these models, they used the WRF to simulate rainfall for the next 24 hours. And so that each one, this was just Basin 2 on May 15th is the center line for each plot. Prior to actually forecasting, they used a radar data set, two different radar data sets, the MRMS, which is the top row, and the stage 4 data set, which is the bottom row. So they ran the previous 24 hours with the observed radar data sets, two different radar data sets, and then that was their initialization for the new forecast of the next 24 hours using the WRF model. So if we advance 24 hours, now the center line is May 16th. And now the previous red line is now the old forecast, which is blue. The forecast is still red in this plot, and same, the forecast is blue. And the black line is the observed stream flow at the headwater catchment for this basin. And the green line is actually the radar data set that was later used at, say, 516 to calculate the initialize the hydrologic model for the next 24 hours. So really the green line is basically running their model with observed data from radar data sets. And just a couple things to point out for both radar data sets, they both overestimated the stream flow quite a bit, but that was due to WRF overestimating the actual rainfall that occurred. But then even when using the HindSat data set, or the radar data, it did a little better job calculating the stream flow at these headwater catchments, but it's still not perfect. And some reasons why it's not perfect is we don't know the soil moisture of the entire basin. And also the radar data sets aren't perfect themselves. As mentioned before, you have the beam blockage that might occur. And so if the data set was perfect and the initialization was perfect, it would be a lot closer to the observation. And one thing I just wanted to point out was that even though the forecasts overestimated the stream flow, it was only off by about 2 hours of the maximum. So this could still be a good tool for flood warnings and flood watches in a certain basin. And thank you, and there's been a lot of help. UNCA has been a big part of these projects. The funding came from NASA and NSF. Who else? The Great Smoky Mountain National Park's been a huge help for our Pigeon River Basin project since we have a lot of gauges there. And there's been many, many other people, private landowners, businesses, schools that have helped with these projects. So, thank you.